All right, here's a continuation of Class 2, where I'm going to discuss adding the vectors by components. Okay, so I think I had, here we go. So section 2.2b, addition of forces by summing x and y components. What you could do, as I mentioned in the bottom line up front previously, is you can break the components into their x and y parts, and then add those x and y parts together to form the eventual solution, right? So we want to have r is going to be equal to rx times I plus ry times j, and that's going to be, we could say that that's equal to the breakdown of these components, and that looks like this over here, which is very useful to us to do this, right? To imagine the x and the y as separate things inside parentheses or separate equations, and you want to try to envision this back and forth, these components. It's very useful, and you could compare it to doing the triangle method or doing the parallelogram method. This right here is, it's not as geometry intensive. You want to be able to do it multiple different ways to be able to double check your results. If you have more than two forces that are acting on there, you could go through these steps right here. Well, you break the forces into their x and y components, you add the components together, and then you figure out what the magnitude and angle of the resultant is. So looking like this right here, we say that Rx is going to be equal to Px plus Sx plus Qx, and then also Ry is equal to Py plus Sy plus Qy, right? And then when we're done, we probably want to find out what the magnitude is. So we take the x squared, square root of Rx squared plus Ry squared. And then we want to find the angle. Now, I personally don't like trying to use the positives and the minuses to establish a quadrant. I instead look and see what quadrant I'm in, and I take the rise and the run, and I find out what the angle is, something between 0 and 90. I don't try to solve it. Like you can put negatives and stuff in there. Unfortunately, there is an ambiguity that can take place depending on whether when it comes to tangent. There's a way to do this in Excel, by the way. I can tell you about something called tan2, where instead of it fixes that ambiguity if you need it. Then the angle can come out somewhere between 0 and 180, either positive or negative. But for us, when we're doing it manually, we just take the rise over the run, and then we make sure that we know what quadrant we're going to be in when we give an answer. All right, so here's sample problem 2.3. And quite often in this thing that we just mentioned right here, if you have a bunch of different forces, it might be in your best interest to make a table, right? So that's what we'll do in this case, because we have we have 4 different forces. So let's try to keep organized here. And whoops, what happened here? Okay, that didn't happen. Okay. Let's go back and let's go for purple, because there's a lot of learning that can be done with the color purple. So I'm going to set this up. I'm going to say that I'm going to go F1, F2, F3, and F4. And I'm going to give myself plenty of room here. Here's my columns. Here's my rows. I don't necessarily have to draw these lines. And then up here, I'm going to say that this is Fx, and I'll put a little I in there, just meaning that there's going to be a bunch of different ones. And I don't know where the best place to make the Y column is, so I'll leave that out. But as I'm marching through, I take a look at F1, and I see that its X direction is horizontal. So 150, and we're going to take the cosine of 30 degrees, and that turns out to be 129.9. I'm not going to bother putting units on there. Then I go to F2 here, and I see that it's going to be negative All right, and then I take the magnitude 80, and this time the way that they've given us the angle is going to be, if we want the x direction, we need the sine, right? So we'll go ahead and be adaptable and do that, and that's going to be negative 27.36. If we go now to force 3, we could see that it's has nothing in the x direction, so it's 0. And then lastly, F4, that's going to be positive in the x direction, so it's 100. And then that's going to be the cosine of 15 degrees, and we find that to be 96.59. Now, it depends what you can sum these up, and if we were to do, we would find that Rx is going to be 199.1 newtons. Now we go for Fyi, and because I've finished everything in the x direction, I can go ahead and decide where my column is going to be. And then, so if we go to y, we can see F1, excuse me, we see the y direction is going to be vertical. So, and then based on this angle, we can know that it's going to be the sine of 30 degrees, and that comes out to 75, right? Which we could have done in our heads, right? The sine of 30 is going to be 0.5. And then for F2, that is vertical and positive, or the vertical component is positive, but now we're going to use the cosine of 20 because it's an adjacent side. And if we do that, we get 75.18. For force 3, it's completely vertical, and it is in the negative direction, so it's negative 110. That was pretty easy. And then lastly, we see F4, and that's going the negative y direction, so it's negative 100 times, and now we want to have the sine of 15, right? Because that's the vertical part of that. Sine of 15. And we get negative 25.88. And if we add up everything in this column right here, we get 14.30. Now, just taking a look quick, this is much bigger than this. So it might be that the vertical component isn't going to give us make a whole bunch of difference in the magnitude. That's something that we might want to have from observation. So if we have for the magnitude, remember we're taking these two components and squaring them. 199.1 squared plus 14.30 squared, and that's going to end up equaling 199.6 newtons. Yeah, you could see that it didn't really change a whole lot from the x because it's mostly x. And if we want to take and we notice that both of these are positive, right? So that does tell us it's going to be up and to the right in the, I guess, first quadrant, right? And so the inverse tan is going to be Ry over Rx, and that's going to give us 14.30 over 199.1. That allows my handwriting, isn't it? You should try to be a little neater. I try to rush sometimes, and that's not good for us. And that's going to be 4.108 degrees. By the way, you could always do, like, if you wanted to, you could also have the inverse sine, right, of 14.30 divided by 199.6, right? Because that's and you would have gotten the same thing. But I don't need that. If I'm going to give this as a final answer in terms of magnitude and direction, whoops, I think I did that earlier too on accident. At least I'm consistent. 199.6 newtons. Actually, you could answer in 3 sig figs. It would just be 200, right? 4.1, and it could be 4.11 or 4.108 degrees. The book goes down, just says 4.1 degrees. That's naughty, and that's a point taken off on an exam. So don't do that. And let's see, I will go and do one last thing here. I'm going to go and try this out in this FET thing. So I'm going to go to the simulation, and demonstrate here. We're going to go to this. We want to try to do this on our phones, just to be some kind of interesting thing, but also to get uses. We're going to go to lab this time. Last class we used Explore 2D. We'll go to lab this time. Let's see, I'll click on it again. And I'm going to turn on values. And we're going to, the best we can do with what we're left here is maybe a scale of 10, right? So our first vector was 80. Was 150. So let me try to get, and it was at 30 degrees. So that right there is probably the best I'm going to do, I think, right here. 15.3, it's instead of 150, we're trying for 15, and 31.6. Because it's snapping to the grid, we can't do much better. So let me try this next one, right? F2 was up and to the left, and it was 20 degrees, right? So that means it's going to be 110 and had a magnitude of 8. So let's see what I can do. Yeah, the 8.5 is about the best I'm going to do here. So let me try that one out. And the next one that we're going to get is, let's see, let's go F3 was completely downwards. And it was 110, so that's going to be like 11. Right? And then lastly, we had F4, which was down and to the right and at 100. So we went like 10 at 15 degrees, or as close as we can. And I think that's about as good as we're going to do. Now, if I were to add these in the order that I've drawn them, that would be like all kinds of weird looking thing right there, right? That's going to be ugly. But I can go for the sum of these, right? And so that's the answer right there. You see that it got 20.1, so that'd be like 200 for us at about 5.7. Now remember, we just got it was at 4. But we've had a bunch of things that are wrong. We have the 15.3 instead of 15. You got 31 points. This is a means of estimating. But this is kind of all ugly and stuff. So if I were to do this, I might like change the order of these maybe a little bit. And so maybe I'll come back over here and over to here, and then down to here. And now I could put this in there, and it looks a lot better than if I just went in a sequential order of 1, 2, 3, and 4. So this is just a means of trying to check yourself, get yourself in the ballpark, but also to see the components. Now, what you could do here is you could turn on these components right here, and you could kind of see what they look like, what the actual values would turn out to be. So that's a valuable thing to do. I'm not sure what these other things are. Like, what if this guy right here? All right, no, that actually might be a better look, right? That you see that we have we come up 8, we come up another 8, we come down -3, we come down -11, and we're left with 2. So I think this is a really useful thing. And now I'll make a screen capture of this right here, and boom, like make sure you have that snipping tool back. I think it comes on most computers now, that guy right there. I really like that snipping tool. And then I can go back into my PowerPoint on this. And I guess I'm in here, right? So I can like end this show right here, and I'll discard this. But I can put in my another slide in after here to show you my results. So I'll keep it for posterity, and I'll paste it, boom, and it's too big, and it wants to give me some designs. I wish I got to learn how to turn that stupid thing off. I do that every time. So anyway, let's see how long our video went. It was a 14-minute video. That's about the most I really want to do. But it gave you a sort of a plan of attack. So far, if this was live in class, that's 2 15-minute videos. That'd be a half hour's worth of material. It's one of the reasons why I'm doing this. So until next time, I will do another example. And let's see what happens.